Okay, we're going to start today on roundabouts capacity analysis estimation. Okay, so basically the intersection analysis model, model generally falls into two categories: either regression analysis, okay, or analytical model. The regression analysis use field data to develop statistically derived relationships between geometric features and performance measures such as capacity and delay. And while the analytical models are based on traffic flow theory combined with the use of field measures of driver behavior, resulting in an analytic formulation of the relationship between those field measures and performance measures such as capacity and delay. For ease of reference, in the following terms we are going to be using. We are going to use VE, okay, for entry flow rate, VC, that's conflicting flow rate, and VX, that's the exiting flow rate. Okay, so the capacity concept for roundabout design, okay, for roundabouts, both of these types of models are applicable. Gap acceptance models are an example of an analytical model and are commonly applied for analyzing unsignalized intersections, specifically at stop signs, okay, because they capture driver behavior. However, we cannot use the gap acceptance model alone in the analysis of roundabouts, because for roundabouts, it has more than just simple gap acceptance models. Okay, so this is the entering volume, this is the conflicting volume, which is basically the volume circulating right before the entry of the approach, and that's the exit volume at the approach. Those are key in determining the capacity and level of service at the roundabout approach. The capacity of an approach decreases as the conflicting flow increases, and that makes sense because, if the conflicting volume, let me just erase this. What we are saying, as the conflicting volume goes up, okay, the capacity for this approach goes down, because there is a little, or the number of gaps that drivers can enter the roundabout through are decreasing with the higher flow rate or the higher conflicting volumes. That makes sense. The other issue in general, the primary conflicting flow is the circulating flow, okay? While the circulating flow directly conflicts with the entry flow, the exiting flow may also affect the driver's decisions to enter the roundabout, because there may be some uncertainty in the. Yes, there's another issue. While you are waiting here in your car, waiting for a gap, some drivers that are essentially exiting, when you see them here, it's hard for you to tell whether they are going to continue this way or going to exit from this way. So again, the exiting volume plays a role, okay, in decreasing or affecting the capacity of the approach. Here, when the conflicting flow rate approaches zero, that means this is almost zero, okay, the maximum entry flow rate, the maximum entry is basically 3600 per H, and H, that's basically the follow-up headway. Okay, that's similar to the saturation flow rate, by the way. Limited priority. This occurs at high levels of both entering and conflicting flow. what we mean with limited priority is when the conflicting volume are high, the conflicting volumes are high, okay, you know, that this is going up and this is going up. Sometimes the priority reversed in the roundabout, especially if the demand here is much higher than the conflicting volume. You see, those are waiting for those to enter. Okay, limited priority. This occurs at high levels of both entering and conflicting flow, in which circulating traffic adjusts its headway to allow entering vehicles to enter. There is priority reversal. In this case, as I mentioned, when the entering volume is much higher than the conflicting volume, you see that they are, you know, taking over, in which entering traffic forces circulating traffic to yield. In these cases, more complex analytical, okay, for these both of these cases, the method that we are going to discuss today is not applicable. For these cases, you need to use simulation. And either VSIM by BTV or SIDRA. Any questions? So here, the single lane roundabout. What is the capacity for the entry lane in case of a single lane roundabout? Basically, the capacity is, as we can see here, it's 1,130 multiply exponent minus 1 multiply 10 to the power minus 3 multiplied V conflicting. Okay, and this is in passenger car per hour adjusted. So that's the capacity of entry. Okay, in case of two entry lanes and there's only one conflicting lane, the capacity for each of entry lanes, for each lane, this is going to be the capacity, which is the same like the one here. However, if we have one entry lane and two opposing lanes, like here, okay, then the capacity of the entering lane will be 1,130 e to the power minus 7 multiplied 10 to the power minus 3 VC. VC is basically the total volume for both directions, this plus this. Okay. In case of two conflicting with two, here the situation becomes different. Basically, the right lane gets this capacity and the left lane gets this capacity. Okay, as you can see, the right lane gets minus 0.7, here minus 0.75. Okay, let's check which one gets more. If we have VC equal 680 passenger car per hour. Can someone calculate this for us, please? So here the capacity of entry for the right lane becomes 702 passenger car per hour. Capacity for entry for the left lane equal
678.56.
678 passenger car per hour.
طالع لي انا 1129.
كم؟
طالع لي 1129.
Can you check your calculations, please? Okay, can someone tell me why this one is higher than this one? Reasoning, some reasoning for this? Okay, the traffic in the left lane wants to have a gap here and have a gap here. But the right lane just needs a gap in this stream. Okay, so this you have much more chances, you have a higher chance of getting a gap here than this one. Here you need to have two gaps together. Okay, any questions? Okay, there is in case if we have a bypass lane. Bypass lane, this is for the right turn traffic. Okay, so the bypass either type 1 or type 2. Type 2, it's not influenced by the exiting traffic. But here, type 1, it's influenced by type 1 by the right turn volume is affected by the exiting volume. But here, the right turn volume is not affected. Okay, so in this case, the capacity, the opposed by one exit lane, then that's going to be the capacity for for this lane. Okay, for the bypass lane. If it's opposed by two lanes, then this is the capacity of the bypass lane adjusted for heavy vehicle, and VC, that's the conflicting flow rate. So this is going to be the capacity for this lane. Any questions? For case 2, there is no formula for this in the highway capacity manual. Okay, you can deal with it as just a single lane and V over C ratio, and you can calculate the flow based on the radius, and you can just deal with it as a level of service, regular level of service highway. Okay, roundabouts design except multi-lane roundabouts exit capacity. The exit capacity has suggested that the capacity of an exit lane according to pedestrians and bicycle traffic in a typical urban area is in the range of 1200 to 1300. Why? Basically, there is pedestrians crossing here, and vehicles are supposed to yield to pedestrians. So if there is a vehicle who wants to exit from here and there is a pedestrian crossing, the vehicle must yield and stop for the pedestrian. Based on that, the German research, okay, in this reference, suggested that the capacity of an exit lane should be in that range. That's an urban area. The Federal Highway Administration suggests that the exit capacity is 1200 vehicle per hour. Okay. However, the analysis is cautioned to also evaluate exit lane requirements on the basis of vehicular lane numbers and arrangement. Okay. Any questions? Now we are going to move to the roundabout level of service analysis methodology. These are the steps that we are going to follow in assessing the level of service at the roundabout. First of all, step one, converting movement demand volume to flow rate. That means we are gonna we are gonna convert all the volume to passenger cars. So here we have volume divided by peak hour factor multiply FHV. We want to convert from vehicle per hour to passenger car per hour. Okay, adjust flow rate for heavy vehicle. That's so basically step one is dividing by peak hour factor, and step two dividing by heavy vehicles. Determine circulating and exiting flow rate. That means if we have a roundabout, we have entering volumes. We want to calculate the entering volume and the exiting volume and the conflicting volume. Okay, so we want to determine the circulating and exiting, determine entry flow rate by lane, determine the capacity for each lane, then determine the pedestrian impedance of vehicles. As I mentioned before, the presence of a pedestrian crossing, this impedes vehicle movements. So we need to adjust for that. Then we convert the flow rates, okay, and capacity into vehicles per hour. Then we are going to compute the volume, okay, to capacity ratio for each lane. Then we are going to compute the average control delay for each lane. Then determine the level of service and compute the average control delay for the entire roundabout, and compute the 95th percentile queue length for each lane. Any questions so far? Okay, we're going to take a break now and we'll be back after 10 minutes. So here we are going to continue on the calculating of level of service at roundabouts, and we go back to, okay. So first of all, so as I mentioned, the first step is basically converting the movement demand volumes into flow rate. So we're going to divide it by the peak hour factor. Then we adjust the flow rate for heavy vehicle, dividing by FHV. Then determine the circulating and exiting flow rate, and also the entry volume, and so on. Let's go to these steps. So that's step one, divided by peak hour factor. Okay, if peak hour factor is not given, we take the minimum peak hour factor, which is 0.94. Okay, then we adjust for heavy vehicles. If heavy vehicles are not given, we take 2%. Okay, and here the vehicle type, passenger car, the passenger car equivalent 1, the heavy vehicle equivalent 2. Then we need to identify the circulating flow rate calculations. That means we need to calculate the circulating flow rate here and here and here and here. Why? Because basically this circulating volume is conflicting volume with this direction, and this with this, and so on. Okay, so for example, the conflicting volume for the northbound, we're going to use the northbound, southbound, westbound notations. Here, that's northbound. This is westbound. This is southbound. And this is eastbound. That means the volume here, this is going to be southbound. So the conflicting with southbound, this is C southbound. Sorry. Yes, C southbound. Okay. and this volume, that's the eastbound. That means eastbound, that means it's going to the east direction. That's east, west, north, south. So the traffic that going in that direction, we say that this eastbound. Traffic going this way, we call it westbound. Traffic going north, we call it northbound. Traffic going south, we call it southbound. Okay? So the conflicting volume with the southbound is going to be C southbound. Conflicting volume here will be C westbound. Conflicting volume here will be C northbound. And conflicting volume here will be C eastbound. Which are these? So this is the C eastbound. This is C southbound. This is C westbound. And this is C northbound. So the conflicting VC, I'm sorry. C is for capacity, but here that's conflicting volume. So the VC northbound, okay. What is conflicting here with the northbound? Let me just grab this and insert it in a new slide. So here يا شباب, VC, the volume conflicting with the northbound, here comprised of what? It's comprised of the westbound that is making a U-turn, comprised of the eastbound that is going through, and eastbound making left turn, and eastbound making a U-turn, and also comprised of southbound that is making left turn, and southbound oops. I'm sorry about that. And the southbound that is making hold a second. That is making U-turn. Okay. Let me just adjust this. Okay. So let's calculate this. So the VC northbound equal the sum of all of these. So we start with the eastbound, V eastbound through, because going this way, and V eastbound left turn, and plus V eastbound U-turn, plus volume southbound, which is here, left turn, okay, plus V southbound U-turn, plus V, this one, westbound U-turn. Okay, let's have an example on how to calculate these volumes, and let's try to solve it. So we have this example from the highway capacity manual. Let's work together and trying to solve this example. So let's calculate for the northbound. So VC, okay, let me just change the VC northbound equals. So it equals this one, 20 plus these two plus the left turn, 175 plus this volume and this volume and this volume, 280 plus 190, that's the left turn volume, plus the U-turn volume, which is 50. Let's calculate the VC, the conflicting volume. So that was VC northbound. Let's calculate the VC conflicting volume for the westbound.
735.
So, thank you, Muhammad. 735 passenger car, or I think this is going to be passenger car per hour. VC, comma, actually this is vehicle per hour, not passenger car per hour. It's not adjusted yet. So this, the correct, it's vehicle per hour. We are going to adjust it later now. So, and the same, VC east, no, I'm sorry, westbound. So that's the conflicting volume with the traffic going westbound. This is conflicting with westbound. So, and what is conflicting with this volume to enter here? Basically, this volume, the through, and this and this. That's to begin with. So it's 210, and that's the point of conflict, plus 105, and that's the point of conflict, plus 30, plus. Is this conflicting? No. Is this conflicting? No. But this conflicting and this conflicting. 190 plus 50, correct? Plus here, what is conflicting? This is not, this is not, this is not, this is conflicting. Plus 20, okay? And this is going to be like this. What's the summation?
605.
605, and this is vehicle per hour. Let's just, before going further, let's adjust for the, you know, the peak hour and the heavy vehicle. Actually, FHV equal 1 over 1 plus 0.02 multiply 2 minus 1 equals
0.98.
0.98. So for the volume to be passenger car, V passenger car equal volume divided by peak hour factor multiplied by FHV. So now we have volume divided by 0.94 multiply 0.98 equal V over So it's V over 0.9212 equal 1.085 multiply V. So this will become multiply 735. So this is 798 passenger car per hour. And this will be 605. So this is 657 passenger car per hour. Let's continue and calculate V conflicting southbound. So we are calculating now the conflicting volume in this side. So basically what is conflicting with the southbound? We're gonna, let me just change the color of the pen. We're gonna start with this. This is the first one, then this and this, then this. This is not conflicting. So in this case, it's gonna be 50 plus 30 plus 105. Please notice with me the way I'm marking these arrows. Plus 20 that's the point of conflict with the southbound, plus 110 plus 395 okay. So these are 1 2 3, I think that's all. How much, Muhammad?
710.
710 vehicle per hour, which can be seen as
770.
771 passenger car per hour. V conflicting with the eastbound, with the southbound. Okay, no, with the eastbound. So what is conflicting with the traffic entering from here? Let's look at it. And let me just change the color or make this green. Yes. So what's conflicting with that? It's this volume, this volume, this volume, and this volume, and this volume, and this volume. So it's basically 30 plus 20 plus 110 plus, now, you know, I just started with this one, 2, 3. You see the sequence? I'm starting anti-clockwise. Plus 20 plus 175 plus 95. This will be
450.
450 vehicle per hour, which can be converted to
488, yes.
88 passenger car per hour. Okay, so that was an example to see how we calculate the conflicting volume or the circulating volume and the entering volume. Okay, so the entering volume, V entry for the northbound, how much equal here? It's all these volumes. All these are entering. So it's 50 plus 210 plus 105 plus 30 equals V
205.
205 vehicle per hour, which equals to how much in passenger car?
222.
222 passenger car per hour. For the entering volume for the eastbound or the westbound, I'm sorry. Okay, here, please notice that you have two lanes. We have bypass and we have this lane. So in this case, we are going to add only those as entering. So we have VE1 and VE for the bypass. Westbound bypass, which is 610 vehicle per hour. And here it's going to be 395 plus 110 plus 20 equals
525.
vehicle per hour, which is how many passenger car?
569.
Passenger car per hour. Okay. Now for the southbound. The southbound, this volume is totally eliminated from the calculation. So V entering southbound equal 95 plus 175 plus 20 equal
290.
290 vehicle per hour. V and
314.
314
14.
passenger car per hour. V entering for the eastbound, okay, it's going to be just the total volume because we have just one entry lane. So here is going to be 50 plus 190 plus 280 plus 85 equals
605.
60605 vehicle per hour, which is 657 passenger car per hour. So now we calculated the circulating volume or conflicting volume and the entering volume. Okay, let's move on to the next step. So the next step here, after calculating the entry volumes, okay, okay, that's the exit volumes here, okay. So the exit volumes is basically the total volume that, entering here. We can calculate the exiting volume also. Let's go back and let's calculate the exit volume, but I'm gonna just change the color. So V exit, let me, oops. let us do the exit volumes here. So V exit, you know, for the southbound, which is exit here, equals how much? What are the volumes that are heading to the southbound? It's basically this 30 vehicle per hour, this one. Okay, let me just grab this. Okay, let me just so it's this volume. Okay, it's going to exit from that point, and this volume plus 110 plus this through volume 95 plus the right turn volume here 85. So the exit volume here for the north, okay, let's calculate it for here. So this is V exit southbound, here V exit, I'm sorry, V exit eastbound. Let me just check something. Yes, here's V exit southbound. V exit eastbound equals first of all this volume that is making the right turn, so that's 50 plus the through 280 plus the left turn 175 plus the traffic that is making a U-turn, which is 20. V exit here northbound equals, you can do the rest, okay? I'm not gonna just go to solve complete. You can complete that later, but you get the idea. So here we're calculating the exiting flow rate and circulation. Then determine entry flow rates by lane. This is basically for multi-lane entries, okay, because we need to identify how much will go, you know, especially or entry with bypass lanes. If there is a bypass, then the bypass will take some of that traffic. Okay, if a right turn bypass lane is provided, the flow using the bypass lane is removed from the calculation of the roundabout entry flows, as we did here, as we did in these two cases, you know, for the eastbound and westbound. You remember here, the entry volume, we took this just for the bypass. For the eastbound, we just eliminated, I'm sorry, for the southbound. Okay. For the southbound, we eliminated the 580 from the calculation. Okay. واضح شباب؟ يعني while we are calculating the entering volume for the southbound اللي هو الفوليوم اللي داخل من هنا كده تمام we took this out of the calculation. Any questions so far? Okay. So basically, if a right turn bypass, if only one lane is available for a given movement, the flow في حالات بيبقى في عندنا one lane وفي عندنا مثلا two lanes. Here بيبقى في حاجة اسمها lane distribution أو volume distribution by lanes. Like this, based on the lane assignment or lane designation. And this we're going to continue next week, inshallah, on this topic. Any questions so far? Thank you and see you tomorrow, inshallah.